right, good morning, everybody. If you haven't already, if you would please attempt to follow those directions. This is going to be a workshop, well, hopefully it'll be an interactive workshop. I've put together a kernel on Kaggle.com, which is similar to a Jupyter Notebook, if anybody knows what that is. But it will contain code and it will contain Markdown. And so if you copy this kernel, then you can follow along with what I'm doing. I did a longer version of this talk, and I had some exercises throughout. I've cut most of those, but I got a couple places where you guys can try to write some code along the way. But you'll probably enjoy it more if you follow along on your own machine. So I'll give everybody a couple minutes for that. As I go, I've got some slides I'm going to go through to get started. I've got the directions on the slides at the very top. So if you haven't successfully done these 3 steps while I'm talking through the slides, the directions will still be up at the top. Let me just sort of survey and see where everybody is in the room today. How many people have used Python before? Just show of hands. So it looks like most of you. How many people have used the Pandas Library? Okay. How many people have never used Python or Pandas? So a few of you. Okay. So we got sort of a mixed group. As I'm going along, this is supposed to be an interactive workshop. It's not just supposed to be me just blabbering on and on. So if anything I say doesn't make sense or you want clarification on a particular thing, just please stop me, raise your hand or just shout out. This is for you guys to learn something, not just for me to talk at you. So again, if you haven't successfully cloned or forked the notebook, you can continue that process as I go through my slides. But I'm going to go ahead and get started in the interest of time. The directions are at the top here, albeit in kind of small font. So this workshop is going to be about exploring the availability of affordable housing in Davidson County, using Python, and specifically we're going to be using the Pandas Library, which is it's sort of the Swiss Army knife of data analysis. If you're in Python, it works very well with visualization libraries and other libraries for a lot of data analysis tasks and data science tasks if you're into predictive modeling. And I'm Michael Holloway. I'm an instructor at the Nashville Software School. I'm the lead instructor for the latest data science cohort, which we just kicked off this week. So for those of you who don't know, Nashville very, very rapidly. 23% population growth from 2006 to 2016, and it's expected to continue growing. It's projected to be 11% growth from 2018 to 2028. And so when you got a lot of people trying to move into one area, you're going to have an increase in home prices and rental prices. There's just not enough supply for everybody. You don't have to look all that hard to see or to find all kinds of articles where people are talking about how this is a big problem. We got musicians having to move they're getting priced out of Nashville. Folks, their rents are going up, and they're having to move further and further out, and they have longer commutes. It's a nightmare. Nashville is among the U.S. cities most at risk of a housing crisis. There's this Wall Street Journal article. Residents worry the metropolis is growing too fast. So the purpose of this workshop is to dig a little bit into the data and see, see the effects of all these people moving in and the supply of homes not growing quickly enough, or the right types of homes not growing quickly enough. So I guess our first purpose is just to sort of explore the supply of affordable housing in Davidson County using Python. Specifically, we're going to be looking at changes from 2009 through 2017. In my next slide, I'll get more into the data set that we're going to be using today. But another purpose is we're just going to learn some basics of Pandas and some visualization libraries for exploratory analysis and visualization. For those of you who just came in, if you would follow these directions at the top, you can clone a notebook so you can follow along with my code. So the data set we're going to be looking at is going to be appraisal data for single-family homes in Davidson County. And so what this means, we're not going to have the whole picture of affordable housing. This doesn't include multifamily structures, apartments, or anything like that. But this is just one piece of the puzzle. Another thing about appraisal data is appraisal values are supposed to reflect what the market price of the homes would be, but that's not always 100% true. So there will be a little bit of error in our analysis from that. But if we're trying to get an idea of the overall picture, this will be one component of that. So, just preface, we're not going to look at all of housing, and we're not going to be able to solve the problem, but we're going to see one aspect of this affordable housing problem in Davidson County. So here's the directions again, full-sized. So if you would go to, if you have a Kaggle account, great. If you don't, I don't think it's too hard to sign up for one. So if you would create a Kaggle account and then go to this bit.ly link, when you go to this bit.ly link, it'll take you to Kaggle. And then if you look in the upper right, you should see something that looks something like this. If you click on that copy and edit button, it will fork my repo over to your Kaggle account, and then you can follow along with my code. So how many people have been able to fork the repo? How many people are still working on it? Okay, I'll give you guys another minute or so. Mm-hmm. Copy and edit, yes. How many people have used Jupyter Notebooks before? Okay, so most of you. So for those of you who have not, Jupyter is a Python library. I guess it's a Python library / web application in a way. It's a way you can import image. If you click in that cell and then press Control-Enter or Shift-Enter, actually I'm not sure what it is on a Mac. It's either Control-Enter or Command-Enter. But if you do one of those combinations, or you click the button on the left, the little play button, then it should bring in this Pandas logo. So try that, and if it doesn't work, then that means you've done something wrong. But if it does work, then you should be in good shape. So did you guys get the Pandas logo? Okay, I think we're good to go then. So we are on Kaggle.com. And as I said, this is a Kaggle kernel. It's not exactly the same as a Jupyter Notebook, but it's very similar to a Jupyter Notebook. It contains, at the top, we have some markdown cells. The cell that brought in the Pandas logo was a code cell. So you can have Python code in a kernel or a Jupyter Notebook. You can do R code in a Jupyter Notebook if you like. You can do Julia code in it. You can do all three of them in the same one if you're crazy, but generally you'll create a notebook with whichever language you're using there. So this, if you click in this top Markdown cell, the one that says affordable housing in Nashville/Davidson County, this is what a Markdown cell looks like. I've done a little bit of Markdown formatting. I wanted that as a header, and so I put the pound symbol there. If I remove that, it just turns back into normal text. But if you guys know any Markdown, you can choose what level of heading you want. If you can do 2 pound symbols, and it'll make it a level 2 heading. But I'll just leave it as a level 1, and if I rerun that cell, it'll format it back. It'll render the formatting back. As we go along, there'll be a couple times where you might want to add another code cell to try something out. To do that, if you just sort of look or hover between cells, you can add a code cell by clicking on plus code, or a Markdown cell by clicking on plus Markdown. For now, I don't need either of those, so I will just continue on. So this first cell, this was just sort of to test that the kernels appeared to be running. This just brings in it just allows me to render images. So that's not really much of anything. So as I said earlier, we're going to be using the Pandas Library. And I think I even said it's like the Swiss Army knife for data analysis in Python. It is very good if you're working with tabular data, so things that come in rows and columns. And it can be non-homogeneous. So you can have one column that's strings, one column that's numeric, so on and so forth. So it's not like a matrix where it has to be all the same type. You can have mixed types amongst columns. When you're working with pandas, if you look at anybody's code who's working in pandas, they will almost always import it as with alias PD. So I'm going to follow that convention. So if you go down, if you scroll down to this code cell and then execute that, then we will have imported the Pandas library. The Pandas library, I guess the big thing it gives you is it gives you the data frame for your tabular data. Not only does it store the data, but it has a lot of useful methods. It works very well with visualization libraries as well. It has some built-in plotting functionality. That being said, if we're going to be working with pandas and data frames, the first thing we need to do is to create our data frame. If you've got an external file that contains the data that you want to manipulate, you can point pandas to it using the read CSV method, that is, if it's a CSV file. And then what that'll do is that will create a pandas data frame. So here I'm going to create a data frame. I'm going to call it houses 2009 because it's going to contain our 2009 appraisal data. So if you guys would run that cell, then unless it gives you an error, then it looks like it's done something. You might be a little skeptical, did that actually do anything? So one thing you can do to check it, if you insert a code cell, and remember to do that, you just sort of hover under the previous cell and then click code. We can check, does it look like it did something? Is there actually a houses 2009 thing in there? I'll just do type of houses 2009, so that's just the base Python method. So if I run this cell, output from this function says this is a pandas.core.frame.dataframe object. So at least the read CSV did something. It takes a little getting used to at first if you're just used to using Excel for data analysis, because in Excel all your data is right there. You can just see it anytime you want. In Pandas, it's stored in this data frame object. But anytime that you want to see that data, you can use the .head method, and that will output the top of the data frame. So this houses 2009.head cell, if you run that, and I've specified n equals 10, so that's going to display the top 10 rows of my data frame. So when you run that cell, you should see something like this. So you can scroll down and see that there are 10 rows displayed. Python starts counting at 0, so they're numbered 0 through 9. But you can see the data. You can see the columns at the top. And so what this data set that we read in contains, it contains an APN, that's just an identifier for a house. It contains a district code, which is for property tax purposes. It contains a council district, an address, and then it contains over on the right side land, improvements, appraised value, assessed value, and then finished area. So what these are, the appraised value, that's supposed to reflect the market value of the home. It consists of the value for the land and the value for the improvements. So if you add those two together, it should equal the appraised value. I didn't check that, but it's probably true. The assessed value is a percentage. I forget what percent it is, maybe 30% or maybe 25% of the appraised value. The assessed value is what the property tax is on, but it's always going to be a percentage of the appraised value. And then the finished area, that's just how big the house is. So that's area in square feet. If you want to check the end of your data frame, sometimes it's a good idea to check after you read in your data set, check the top attribute. So notice we don't need a parentheses on this one. But if you run that, then we see we get a number of rows and then a number of columns. So here we have 183,000 rows and then 11 columns. So this contains, I believe it contains every single family home in Davidson County. Just some more general getting to know your data set methods. .info is another good method to run when you're trying to get to know your data set. What it gives you all the column names, and then it tells you what type is stored in each column, and then it tells you how many non-null entries there are in each column. And so in this case, we saw earlier, that there were 183,406 rows in our data frame. And we're lucky in this case, this doesn't always happen, but every single column of 3,406 non-nulls. So if you had any missing values, those numbers would be lower. But here we're lucky, we got everything. Not only does info tell you how many things there are, but it tells you what data type they are. Pandas will try to infer the data type when you read in the data set. It's not always correct. It does a decent job, though. But here we have some objects, some ints, and some floats. So you guys probably know what ints and floats are. Object is it's basically a string to pandas. If it can't infer any other type, it will just plop it in as an object type. That's fine most of the time. If you're working with a particularly large data set, you might want to convert those to the correct type because objects take the most space up to store them. So if you have 10 million rows or something, if you're working with pandas, you got to work in memory, and so you can free up a little bit of memory by giving it the correct types. But here, less than 200,000 rows, not a big deal. We'll just go with what it read them in as. If you just want to see the column names, you can access those with the .columns attribute. Now, if you don't want the whole, there's a couple ways you can access it. The first way you can do it is by using brackets. So if you take the data frame name, and then you do a bracket, and then you pass the column that you're interested in as a string, which means it's got to be in quotes. If you run that cell, what it returns what's called a Pandas Series. So a Pandas data frame, each column is a Pandas Series. A Pandas Series is like a list of values, but it's even better than a list of values. It's got an index, so you can see those numbers 0 through 183,000 again. Those are sort of the addresses to access entries in that column. So it's got the index first of all, but then it also has a lot of useful round it out with some, I think, an interactive plot at the very end. Sure. So you can get appraisal data one house at a time from the, I think it's the property assessor's office for Davidson County. I got it from Sean Braistad. He's the, let's see, what is he? The information officer for codes, I think, for Metro. I got the whole shebang from him. But it's all open data. You can go look up your house. I guess you could look up your house in this data set, or you could go online and look it up. I couldn't find a way to get the whole thing like from the website. Maybe there is, but I got it from him, though. Okay, so let's get into some slicing and counting and some exploratory analysis. So what, I guess to get an overview of your data, maybe one of the first things you would want to do is just to see what all different values are contained in a particular column. And the .unique method is good for that. So if we want to know how many different cities are represented in this data set, the way you can do it is you take your data frame and then you can say dot and then the column you're interested in. So if I want to know what cities are there, it would be address city and then .unique. And so let me just show off this tab completion again because I think it's cool. So if I were typing this in, houses 2009 .address C, I could hit tab and it would complete that to city, and then I could say .u, and then if I hit tab, it'll think for a second. Maybe it's going to prove me wrong. It's thinking for more than a second. All right, I guess it is going to prove me wrong. So if you're in a Jupyter notebook, I promise it'll work. But here, if we do addresses or address city.unique, we can see here's a list of all the different cities that appear. So, no surprise, I guess Nashville, Old Hickory, Antioch. There's a couple weird ones. Franklin snuck in there somehow, and Laverne snuck in there somehow. So you might ask, too, like, so here's all the different cities that are represented. How many times are they represented? What's the most common one? You can probably guess what the most common one's going to be in this data set. But if you want to know, the value counts will do that for you. So if we do address city.value counts, then what that returns, it returns a series, and that series will have each city that appears and then how many times it appears. And so we can see, no surprise, Nashville is the most frequent address, 126,000 in there, and then followed by Antioch, Madison, and so on. So three Lavernes snuck in there, 24 Franklins, etc. Let's talk about filtering. So what if we want to pare down our data set to a specific subset? So one way you can do it, there's about a half dozen at least ways to slice a data frame. But one that I usually go to is the .loc method. So .loc, I think loc is, actually I'm not sure, locate or something. But the way it works is you sort of give the address for the data that you're looking for. So I pointed out on the left side of the data frame and of the series, it had those numbers 0 through 183,000. That would be one part of the address. And then your data frame also has those columns at the top, so that's the second part of your address. You can also get an address by passing an array of Booleans. So if there's a particular condition you want to check, you can generate a list of Booleans, and then you can give your data frame, or you can give .loc those Booleans, and it'll slice down according to the values of those Booleans, the true or the false. So if we were interested in homes in Brentwood, for example, we can start by generating a series of Booleans, so a series of trues or falses, by just putting that condition equals Brentwood. So this is going to go through the address city column, and it's going to check each entry. It's going to say, is that equal to Brentwood? If so, you get a true, and if not, you get a false. So if you run that cell, Here we see a bunch of falses, but we see some dots in the middle. So at least the top and the bottom weren't in Brentwood, but there were probably some in the middle there. So what do I do with that? I take that Boolean series, and then I pass it into .loc inside those brackets. You actually don't even need the .loc in this case, but we're going to need .loc again later, so I wanted to use it. But if you pass in that Boolean series, the one that checks if it's equal to Brentwood, then what I get is I get a data frame that contains just homes in Brentwood. Oops, I can't get out of here now. All right. Does that make sense to everybody, or close to make sense? You can also use .loc in this way. You can use .loc by passing rows and then columns that you want. So that's the index on the left and then the index at the top. So for example, if I was for some reason interested in the 100 through the 105th entries, and I wanted their address and their city, I could pass it into .loc. So again, this is rows first, and then the columns that I want. And so that will return for those 6 homes. Here's the address. They're all in Jolton. You can even pass in like a list of values that you want. So if for some reason I want the 1,000, 2,000, and 3,000 rows and the council districts, I can do that, and it'll return exactly what I called for. So again, you can think of those index values as sort of an address for the data in your data frame. All right, so that's enough of that. Let's look at some plots. So as I said earlier, Pandas has built-in plotting methods. It basically has Matplotlib, the Matplotlib library under the hood. Unfortunately, the default Pandas plots are a little bit ugly. And so to pretty them up, to make them a little bit more presentable, I'm going to go ahead and import the whole darn Matplotlib pipeline module. If you see any code where people are using Matplotlib, they almost always alias it as PLT. So I'm going to do that convention as well. Now this funny guy right here is an IPython magic. So it's not exactly a bit of Python code. It's sort of a direction to our Jupyter notebook, or in this case, our Kaggle kernel, that says I want to display my plots in line. So when I create a plot, I want you to show it to me right there in the notebook. It may not. Are you talking about this one right here? Oh, so I think if you try to do rows and columns, it does. If you're doing a Boolean, oops, you have to spell it correctly though. If you pass like a Boolean value, you can slice it without the .loc. I just always default to using .loc, but it's not always necessary. There's like 3 or 4 other ways to slice as well. Okay, so let's go ahead and import the Matplotlib library, or rather the PyPlot module. And then let's see how we do a plot. So let's say we were interested in looking at the council districts, and we wanted to know just how many homes are in each council district. So I'm going to take a little bit of code from what we've already seen. So we saw value counts earlier. Value counts just tells you how many there are per category. So if in fact, I'll copy this and paste it in a cell right here. And so we can see if you just run value counts without the plot stuff, it returns a series. And what this series says is that in Council District 11, there are 6,935 homes. In Council District 33, there are 6,895, et cetera. So if I take the resulting series, I can use the .plot method, and then I'm going to do a bar plot, so I'm going to say .plot.bar. You can do bar plots, you can do histograms. We'll do a histogram in a minute. I think you can do scatter plots this way as well. You could do several different types of plots. But if I do, again, take my series, the value count series called .plot and then .bar, what it gives me is this rather ugly looking bar plot. It's a bar plot, but it's kind of ugly. So as I said, the default plots don't look the greatest. If this were like you doing some exploratory analysis, I guess this would be fine. You could read this and then figure out what you wanted. If you wanted to present this to somebody, you probably wouldn't want to show them this plot. This is pretty bad. The colors are not the greatest. These labels are sideways, which looks funny. Has no title and no axis labels. So let's see how you can pretty it up a little bit to make it more presentable. These plots are highly customizable. You can, whatever you can dream up, you could probably make your plot look like that. Matplotlib to do that. There are about 50 different stylistic options you can pass into your plot call. Here's a link to just a subset of those. This will give you some of the options, but there's even more options if you dig deeper. I'll just highlight a few options that I think would make our first plot look a little bit nicer. So you pass these options usually, not always, but you usually pass them into your .plot.bar call. But there are other ways, and in fact, you can even see where I've set my labels and set my title outside of that call. It just varies depending on what you want to do. The options that I've chosen for this particular bar plot, I changed the fig size. So the default size is a little bit small. So I've set the fig size, and I can never remember. I always have to do it both ways because I can't ever remember if it's width height or height width. It must be width height though, because I have 35 districts, so I would probably want it wider than tall. The width option, which is slightly cut off, but the width option inside bar is the width of your bars. This rot, that's rotate. This is how much you want to rotate the X labels. So remember, by default, it puts them sideways, and that's usually fine if you have long strings or something. You wouldn't want them horizontally because then they'd run up against each other. But since they're just numbers, we could do no rotation. And then color is just what color you want for your bars. You can even color them by height, but we'll not do that. Now I've done something else that may look a little bit funny at first glance. So before, when I called .plot.bar, I just said houses 2009 blah 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 .plot.bar, and that was it, and it rendered the plot. Here I have actually assigned this to a thing I've called fig. So what I'm doing is I'm saving the figure that generates as fig, and then that lets me go in and change the labels and the title. So if you save it as a fig, you can say fig.setXlabel and then whatever you want to label it as. And you can say set title and then whatever you want to title it as. And you can even change the font options. So all I've done here is I've set the font weight to be bold for the title. You can set the font size. You can even set what font you want. But I'll just go with the default for that. And so if you run that, you end up with something that's a little too big to fit on my screen. But you'll have number of single-family homes by district, title at the top, and then the district along the bottom, and then your bar plot. So I think that looks a little bit better than the default. I would almost be willing to show that to somebody else. There is one thing that I don't like about this. So you may notice that the bars are just plotted in order by height. And so like council district, it starts with 11, 33, 4, etc. So it always just plots in the order that you give it to the call as. And so why did it plot it in that order? Well, value counts returns things in order by count. So Council District 11 had the most homes, so it was the first one in our series. So when we plotted it, it was the first one on our plot. And that might be fine, I guess, depending on your preference. To me, it seems like, well, these are council districts. They're numbered 1 through 35. It might make sense to just plot them, 1 on the left and then 2, 3, 4, and so on. So how can we do that? Well, we can do it by using .loc. Actually, I think here you don't even need .loc either, but I'm going to tell it, when you do this value counts call, just rearrange it in the order of range 136. So if you aren't familiar with Python, when you say range and then a number and then another number, that just says all numbers between the starting number and then the last number, not including the last number. So range 136 is going to do 1, 2, 3, 4, 5 all the way up through 35. And so if I pass that into my loc call, that will rearrange the indices according to the order that I want. And so I do that. Well, so that's what it looks like. I guess this is not the plot. But if I do that .loc call, it arranges the indices in that order and the values, of course. And so I can redo my plot call. And so I get bar plot districts in the correct order. All right. Any questions before I move on? So that was a bar plot. That's good if you got a bunch of categories like council districts. You want to know something about those council districts. If you want to look at a distribution of values, a histogram is what you want to go with. And so let's say we wanted to look at the finished areas of homes in Davidson County. We wanted to look at the distribution of that. Instead of saying .plot.bar, you can say .plot.hist. And then I'm going to go ahead and specify a figure size and give it a title. But we get this lovely histogram of distribution of homes by square footage by using that. Isn't this so informative? So the problem, I guess, with a histogram, at least if you just go with the defaults, is that sometimes you have some just very extreme values. So in our case, so when it does this plot, it's not going to put this weird long x-axis there unless there's something out there. So what that means is that there's some ginormous homes in Davidson County. So we've got at least one that's close to 40,000 square feet. But there's not very many of them because you don't even see any bars along there. But so if we just go with the defaults, that doesn't really tell us much of anything besides that the majority of homes are less than 5,000 or probably less than 4,000 square feet. Big surprise. So what if we want to get a reasonable histogram where we can actually see something? So the way we can do that is we can slice our data frame down to reasonable sizes. I picked 10,000 square feet. That seemed like a reasonable amount for me. So I'm using this .loc. Probably don't need the .loc here, but I'm going to do this, generate this Boolean series, checking if the finished area is less than 10,000 square feet. But then I can then pass that into my .plot.hist, and I get this maybe slightly better histogram there. And so you can see most homes are less than 2,000 square feet, and it looks like the peak is around 1,500 square feet or so. Oh yeah, I did snuck something else in on you. You can specify how many bins, like how many bars you want in your histogram by specifying bins equals, and then whatever number you think is appropriate. 50 seemed okay to me. But that allows us to get a better idea of the distributions compared to the first one. Okay, now who cares about square footage? I guess it's something, but we're talking about affordable housing, and so probably appraisal values are going to be what we'd be interested in. So if we try just the total appraisal values just to start with, we're going to get a similar story to with square footages. In fact, it's even worse. So we get the phenomenon of everything on the left except a few weird guys out to the right. And it's even worse because now we're using scientific notation. So it's these numbers on the bottom. It's 0 point something. That's because it's 10 to the 7th power. So that's like $10 million. So this says that there's a home that's appraised at like $10 million. And there's, I guess there's a few that are really appraised very highly, and then most of them are not anywhere close to that. So we can try to trim it down so we get a better picture. Now you might say, well, what's the overall distribution look like? So if you have like no idea at all what a good cutoff might be, you can use .describe on a column. If you use .describe on a column, it will give you some summary statistics information. So this is the total appraisal values column. We can see there's 183,000, but we already knew that. But this gives us average. So average is about 200,000. You have a standard deviation if you want it. The smallest one is what is that? 1,400. That's probably a house that's not complete yet or something. But the max value, there is a $10 million home in there. But the 75th percentile is at 220,000. It's not much higher than the mean, but it's 220,000. So what does that mean? That means that 75% of the homes in Davidson County are appraised at 220,000 or less. So armed with that knowledge, we can look for what's a good cutoff. I landed on 750,000. And using 750,000 as my cutoff, I get this histogram, which, it's not necessarily the best histogram, but it's more informative than what we had before. And so we can see that right around 150,000, 140,000 is where the biggest number of homes are appraised. And then it tails off out to some really big, expensive homes. So this was 2009 data. We want to look at how it's changed. So if we want to look from 2009, we have 2009, 2013, and 2017 data. So let's bring in that 2017 data and compare. If you have multiple plots, if you just keep calling .plot, then most of the time you'll get your plots right on top of each other. And so if we want to compare distributions of home values or home appraisal values, that's probably a good thing. We can just plot our two histograms on top of each other, and then we can get an idea of how the distribution of appraisal values has changed. When you do that, you can pass in an option, an alpha option. So alpha sets the transparency value of your plots, of your bars. And so if we have two histograms on top of each other, you probably want to set that alpha to something less than 1. Alpha equals 1 means totally opaque. Alpha equals 0 means totally transparent. So I'll put it somewhere in the middle. I did pass a couple other options in here. I put label values so that when we do our legend, it will know what to label our histograms as. And what else did I do? Oh, I set density equal true. Which again, it's sort of a preference. So this will plot, instead of just number of homes, it'll be percentage of homes in each bin. But if you run this code, if all goes well, you should get a picture that looks a little bit like this. So and I'm colorblind, so I don't know what these colors are. What is this, bluish, I guess, and then red. I'm probably way off on that. So this is 2009. This is what is this one? 2017. So you can see how the distribution of appraisal values has changed between those years. In 2009, we had a lot of homes in the range of 140, 150,000. By the time we get to 2017, this whole distribution is shifted to the right. And so we have like a peak closer to 200,000. And so these home values are just getting driven up by quite a bit, enough to shift the distribution way over there. Mm-hmm. That's a good question. So if I don't do that, so if I comment that out, I end up with a y-axis that's, so these are density values, not counts. And so, I guess it's informative, but it's not really all that informative. It says, actually, I don't even know how to read this correctly, but it's like 0.0007% or something of homes are at that height. So just because it's confusing to me, and if I handed this off to somebody else, they would say, what in the world is that Y values? I just turn that off. So I just have the distribution. So I guess it's not as precise of a picture, but if you're just trying to get a feel for how appraisal values have changed, I think it's good enough. All right. I'm going to talk a little bit about aggregating values. So we've done a little bit of aggregation already. We were looking at like number of homes per council district, which would be a count. But if we don't want counts, if we want like averages or medians or whatever you can dream up, what you want to go with in Pandas is the group by method. And it makes it relatively easy. There are a couple of weird things about using group by that I'll point out when I get to them. But the basic syntax for using group by is you take your data frame, and then you say dot group by to call the group by method, and then you say the column that you want to aggregate on. So if I want to group by council district, I would pass in council district. And then after that, you have to tell it how you want to aggregate it. And it's got a few built-in aggregations. You can do counts, you can do means, you can do medians, you can count number of unique values, etc. Here I'll just do a count, and we'll get a result which is very similar to what we got earlier when we did value counts, except it looks funny. So this call I did group by council district, and then I said give me a count. And the result looks like this. It's a data frame, but it looks kind of funny. Column, it has like an identical number. So we have like for District 1, APN we have 5906, district code we have 5906, full address we have 5906, etc. Second row, it's all a bunch of 4342s. So why did it do that? Well, when you group by and then try to aggregate, by default, it's going to aggregate every single thing it can, every variable that it can. And when it comes to counting, you can count anything. And so that's why we got a count associated with each column. And, I guess that is sort of okay. But if you would rather not have a bunch of duplicate columns, then what you can do is you can specify exactly what you want to aggregate. And so if I change my call, if I say group by council district, and then I just say, just count the APNs, if you're doing a count, it really doesn't matter what you choose. So I'll just choose APNs. If I run that, it will return something that looks very much like a value count call. It's just council district and then the count by council district. Now, if all of this, or if this were just the same as value counts, I wouldn't be pointing it out. But group by allows you to aggregate using other functions. So if we want to look at total appraisal value by council district, we can use a .mean. And so we can see in council district 1, the average appraisal value was $144,000. Council district 5 was relatively cheap in 2009, less than $100,000 on average. If you scroll to the bottom, council district 34 was really expensive, $619,000. Anybody know where council district 34 is? It's Brentwood. So yeah, if you know Nashville, it's not a big surprise. The Brentwood area has humongous appraisal values. You can even aggregate on multiple functions if you want. You have to use the dot. Well, I say you have to, but there's probably other ways to do it. You can do it by using .ag instead of just calling the function and then just passing what you want. So if you want to look at mean and median by council district, you can. And so if we look at that, the picture for Brentwood, it's slightly better. The median value is only $500,000. It's only $500,000 median home value for Brentwood. But you can see some of these districts get skewed because you have some very expensive homes there. Yeah?
How would you, for the one above it, the mean,
Mm-hmm.
how could you put those in like an order?
I think you can. I'm not sure this is going to work, but I think you can say dot sort. Let's see. Nope, that's not it. Does that do it? I guess it does. And so it sorts in ascending order, and I think you can say ascending equals false if you want to put them in the other order. So you can really go crazy with aggregations. You can aggregate one column multiple ways. You can aggregate multiple columns multiple ways. You can group by, I think I have one cell down here where you can group by multiple columns and then aggregate. So if you want to go completely nuts, you can aggregate multiple columns, or rather you can group by multiple columns and then aggregate multiple columns using multiple aggregations. But here you can, if we group by council district and then postal code, we can get some very fine-grained detail. So for postal code 37015 within Council District 1, the median appraisal value is $112,000. I don't know if anybody would ever need to know that level of detail, but you can if you need to. Okay, so we're trying to understand, like, where is there a need for affordable housing, or where are there shortfalls? So I'm going to bring in some income information. I got this information from the census. So I pulled in median income information by council district, and I've got it stored in this acs.csv file. So I'm going to go ahead and read that in. I'm going to set the index to district. I'm just going to say I do that for a reason, but to save time, just believe me that is important. And so if I bring in that median income information, I can put that median income information together with the appraisal value information if I want to get some idea of maybe which areas of town there is a problem. And so what I'm going to make a scatter plot this time. So we've done bar plots, we did histograms. I'm going to do a scatter plot. I'm not going to use the Pandas scatter plot method. I'm going to use the Matplotlib scatter plot method. But the basics are you say plot.scatter, and then you tell it what you want on your x-axis. So here I'm going to take the median income information on the x-axis. I'm going to take the appraisal value on the y-axis, and then I'm going to just add some labels and set the size. And so if you do that scatter plot, you get this sort of picture here: median income and then appraisal value. So let's think about what the scatter plot is showing us and what we can get from it. So we have median income, just on average how much people are making in each council district on the X. So I guess richer districts to the right, districts with less income to the left. And then we have appraisal values on the y-axis. So cheaper houses towards the bottom, more expensive houses towards the top. So if we're trying to identify which areas of town might there be a problem, to me, and I guess there's various ways that you could define what is a problem, but to me, I would think areas where there are lower incomes and home values are higher, because in those areas you have people with not enough money to pay for their homes. And so if we try to identify where that is on this scatter plot, that would be lower incomes would be to the left, higher appraisal values would be up higher. And so a few of them stand out. It looks like these three, especially this one right here, looks like there might be a problem in that district. Incomes aren't high enough compared to the appraisal values. Even these guys throughout here might be a problem. Maybe that guy up there could be a problem. This is not an exact science here, picking out the problem districts, because of course we're looking at aggregate values, we're looking at median values, so this doesn't tell the whole story at all. But just if I was sort of digging through the data trying to figure out where might there be a problem, I would immediately point out those districts. Now your next question might be, what are those districts? We just have a scatter plot and we have a point for each district, but how do I know which one is which? So if you really like slicing data frames, I suppose you could try to identify it based on the median income, but that's a big pain. So what would be better is if I just had labels on my plot, or at least that's what I think. If I just had those labeled as this is District 1, this is District 2, then I could look at it and say, okay, I got a problem in District X. So how do we do that? Matplotlib has an annotate function. Annotate will add text to a plot. You just have to tell it where you want that text to go. And so you specify that by giving an XY argument. And then you got to tell it what text you want, and you specify that using S. And so I'm going to wave my hands a little bit here, but what I'm going to do is I'm going to do a for loop. And what that for loop is going to do is it's going to go through the values 1 through 35, because we have 35 districts. This will find the XY coordinates of that point, and then I'm just going to put as my annotation, as my text value, just the string of whatever number I'm on. So when it does 1, it's going to find on the scatter plot where the council district 1 is plotted, and then it's going to put a number 1 on that. And so if all goes well when you run this cell, then we should have numbers attached to each point. And again, this is not the prettiest thing in the world, but I think it does the trick if we're just trying to identify problem districts. And so the big ones that stand out are council districts 17, 19, and 6. Anybody have any idea where those are? We'll see how well you know Davidson County. Map at the end where you can see these. But council district 19, that's right downtown. And it includes Germantown as well. Council District 17, that's a little bit south of downtown. If you go down Nolensville Pike, it includes Berry Hill, that area. Council District 6 is across the river from downtown. It's in East Nashville. There's a couple other districts. 5 and 7 are a little bit on the high side. Those are also in East Nashville. So 5, 6, 7, 17, and 19. Those are all downtown and then right across the river from downtown in East Nashville. So those are areas where maybe incomes aren't keeping up with appraisal values. All right. Everybody still good? All right, so let's dig into these appraisal values some more. Let's see, when do we end at 10:30? 10:30, okay, I got 25 minutes. We'll see if we can make it to the end. So let's look more at these appraisal values. I think we've already used this .describe, but let's do it again. So I think we described 2009. If we look at 2017, there's actually an $11 million home now. And I'm just curious, so if you want to know, where is that $11 million home, or just where are all those expensive homes, Pandas makes it pretty easy. You can use in largest, and you can filter down to the largest appraisal values. Here, in equals 5, I'm going to look for the 5 most, or the highest appraised values. You have to tell it which column you want to find the largest of. But if you do that, just out of curiosity, we can see the most expensive homes in Davidson County. So this one is appraised at $11,500,000. And there's even the address. So if you go on Google Maps, you can see what does this very expensive home look like. But there's that one. Looks like there's another $11 million home, a couple $10 million homes, and then there's a bargain here at the bottom, just a $9.2 million home. So sometimes, again, when you're doing exploratory analysis, sometimes you're interested in what's at the top, what's at the bottom. And so in largest, in smallest come to the rescue for that. Okay, so let's look at how the picture has changed across the range of years that we have. So we have 2009 through 2017. Let's look at which districts have changed the most.
It's actually 15.
1015, really? Oh, shoot, okay. Well, maybe we'll look at changes per district, and then you'll have some plots to take, you'll have some leftovers to take home with you. So if we want to look at how appraisal values have changed, yeah, I'll not rush through it because I don't want to like, is it 10:30? Okay, so I'll still try not to rush too much. So if we want to compare how these appraisal values have changed from 2009 to 2017, currently we have 3 separate data frames, one for 2007, one for 2009, 13, and then 17. I'm going to glom them all together into one massive data frame. Before I do that, I better put a year column. So if I do, so these 3 lines here, where I say, how's this 2009 year equals 2009, what that is going to do, it's going to create a new column, and in that column, it's just going to put a 2009 in every single spot. So you can, I think that's called broadcasting a value to a column. But if you take your data frame and then you do bracket and then a column that doesn't exist yet, it'll create that column, and then it'll put whatever you tell it to put in there. And it can be more complicated than just a single number. We'll see that potentially if we get to it a little bit further down. So once I do that, I can stack them on top of each other by using the concat method from Pandas. And so when you concat, you just pass a list. So you put brackets and then the data frames you want to concat together. This will get mad at you if they don't have the exact same column names. It may or may not work, but it'll like say, hey, there's something funny going on here. But here I was careful, or I tried to be careful, and so these data frames should have the exact same columns, and so I should be able to concat them together. And at first glance, at least there's no obvious errors, and so it looks like we've done something. So if you scroll over, it looks like they're all 2009, but that's because we can only see the top. If you go further down, there'll be some 2013s and 2017s. Okay. So I'm going to, did you have a question?
Well, I was going to let you know that if you're interested, that $11 million home is for sale for $15 million.
Oh, okay. Well, there you go. So I guess that goes to, well, I guess these were appraisal values in 2017, so it's you know, maybe they made some improvements to it. It wasn't good enough. So I'm going to like to look by council district and look at how the median appraisal value has changed from 09 to 17. And again, this is sort of from far back. We're looking at aggregate values, so this doesn't tell the whole story. But I want to compare how each district has changed compared to overall Davidson County. And so I'm going to compute an overall percent change in median appraisal value. So that's a lot. I just said a lot of words. But this cell, look away if you if you like. But this just, it takes the difference in appraisal or median appraisal value overall for 2017, 2013, and then divides by median appraisal for 2013. So that's percent change in overall appraisal value. So overall across the whole county, appraisal values, median appraisal value has gone up by 45%. Now I want to look by council district so we can figure out where in town there's the biggest problem. So I'm going to use group by to aggregate and get median values. Now in the interest of time, I'll say to make this work, I have to do what's called resetting the index. When you aggregate, it creates, or it shifts your index to what you were grouping by. And that's fine in some cases, but in other cases, you don't want that to be the case. So what reset index does is it shifts your index column into a regular column, and then it just creates a new index that just numbers 0 to number of rows. So I'm going to do median appraisal values. And so after I reset the index, what I have is I have a council district, and then I have a year, and then I have a median appraisal value for that council district by year. I would like to look at percent change in median appraisal value And so what that means is I need to compare median appraisal value from one year to another year. Right now, after I did that aggregation, the result is I have, for each council district, I have 3 rows, one for 2009, one for 13, and one for 17. And you could maybe do it if you're clever enough, but I'm just not that clever. So what I want to do is I want to pivot my data frame. So if you've used pivot tables in Excel, it's kind of the same idea. I have values in a column, and I would like to take those values and turn them into their own columns. So in this case, if I want to compare across years, it would be nice if I had just a column that said, in 2009, the appraisal value was this, in 2013, it was this, in 2017, it was this, and just one row for each council district. And so I can do that if I use a dot pivot. So to use dot pivot, you do your data frame dot pivot, and then you tell it, I want this to be the new index. I want to pivot. I want to turn these into the columns, and I want to fill them with these values. So I'm saying this fast because I have 15 minutes, so block me out if it's confusing. But after pivoting, what I have is I have a row for each council district, and then I have a median appraisal value per year per council district. And from that, what I can do, and I just pointed out here, after you do that pivoting, we have integer columns, and so you have to be careful when you're working with columns that are integer named. In that, like for example, in this next cell, I'm not putting quotes around them anymore, I'm just using them as numbers. But what I can do is I can create this percent change column for each council district using that same percent change formula, and so I end up with, in Council District 1 from 2013 to 2017, median appraisal value grew by 33%. It grew by 42% in Council District 2, et cetera. It does, yeah. Recession. So yeah, the market, like for the most part, it was pretty flat. It might have even dipped just slightly down, and then it kind of recovered by the time you got to 13, and then it takes off from 13 to 17. I got to make it look more dramatic. You get the bigger jump over that. Okay, so what am I doing here? Oh, I'm just resetting the index. And then we'll build up a plot. So I'll go through this quickly again because of time, but I'm going to start with a basic scatter plot by district. And so I just have a point for each district where the height is equal to the percent change. And so like Council District 1, less than 40% change in median home value. Council District 5 is way up there, 120-something%. Council District 5, that is right across the river from downtown in East Nashville. To spruce up this plot a little bit, I'm going to add a horizontal line. Remember, I calculated the overall Davidson County percent change, and so I'm going to add this horizontal line here just so we can compare each council district across or against the whole county, see which ones were above average growth. And then I'm going to continue to wave my hands a little bit, but I think to emphasize that change, I don't really need that cell, but to emphasize that change, I think it would be cool to have like a line that goes from each point to the average, just so like, you can see, oh, this one is way higher than average. And then we'll do one more bit of, I want to get to my cool plot at the end. So I'll just say, you got the code there, but to spruce up my plot just a little bit more, just to emphasize, this district, it had crazy growth. I just added some annotations there and then pointed out that's the percent change for Davidson County. So Council District 1 experienced very, very rapid growth, or rather District 5 did. 5, 6, and 7 were all quite a bit above average. I don't know what those, I think that's 16, 17, 19, 20, and 21 also rapid growth. So Council District 20, I don't know if you guys know the Nations neighborhood. That's Council District 20. So that's one of those districts where home values, the median home value went up by 80% from 13 to 17. And it's probably gone up even more since then. So remember I said I had some exercises originally, but I decided I just don't have time for those. So you got an exercise, you can take that home and try it out. All right, so I've got a couple more plots I want to share with you guys. So a little bit of terminology to preface these last plots. When you go to like HUD or even the Metro Council, they're concerned about what they call affordable housing and workforce housing. And so they have precise definitions of what they mean by affordable and workforce housing. I guess I'll give you the abbreviated version. Basically, HUD is worried about people spending more than 30% of their income on housing costs. And so they're looking at which houses would not, so if you're spending more than 30%, they say that you're cost burdened. So for affordable housing, they're looking at which houses would not cost burden lower income people. And for workforce, they're looking at which houses would not cost burden people that are making closer to sort of the median income for that area. And so I'm gonna adopt their affordable and workforce housing terminology for these last couple plots. Here's some, I guess, sort of more precise definitions on what I'm going to use, but I don't want to jabber on too much. So how are we going to calculate this? So we have appraisal values. Now, those appraisal values are sort of a proxy for market values. It's not a perfect proxy or anything by any means. Based on those, we can estimate again. So we have like two levels of estimation going on here, but we can estimate mortgage payments based on those appraisal values. So I've written this function just to calculate a mortgage payment, assuming a 30-year mortgage at 4% with a down payment of 20%. You may or may not agree with those, but that's what I'm going to go with, just so I have a number to work with. And then I can create an estimated mortgage cost column. Remember earlier we added on a year column by saying I want the year column to equal this thing. I can do a similar thing, but I'm not just broadcasting a value function above to calculate those. So it's going to go through that column and it's going to calculate an estimated mortgage cost. It takes a second on that one. Now when you have a house, you have mortgage costs. You also have property taxes. And then you also have insurance costs. And so I pulled in the tax rates. Remember, there was a column that was associated with tax rates. So I wrote a function to calculate property taxes. It gives an error the first time because we've got some stray white space. That's a common thing that happens. If you have stray white space, you can strip it out with .strip. That's a sort of a base Python method. But you can calculate estimated property tax. And this one actually takes a second. I didn't make it as efficient as I could have. But we got to wait a second on that one. I guess we have to wait more than a second on that one. There we go. And then finally, we can add in, and I have no idea if this is a good number or not. I just said $720 a year for insurance costs. I'm going to take the mortgage cost, property tax cost, plus $720. And this one, I think, oh, that one's pretty quick. Now I'm going to, just so I can chop these up into different blocks, I'm going to chop it up into affordable 1 and affordable 2, and then workforce 1, workforce 2, and above workforce. So in short, affordable 1 would be houses that people making just 30% of the area median income could afford. And then affordable 2 would be people making 60% of the area median income. So if we're looking for, where is the affordable housing, it would be in one of these two categories. And then workforce would be people making closer to the area median income. And then above workforce is where you got to be rich, or relatively rich. So I wrote a function again to do that, and then we can apply that. I should have run this because this one takes a second too. I should have written some jokes. I could fill in this time here. There we go. All right, so we have our categories. And so just to get a quick peek at what this picture looks like, and so I can re-explain what those categories meant, we can do a very quick bar plot here to look at number of single-family homes by category for 2017. So the way I've labeled this first category, affordable 1, this would be affordable to people making only 30% of the area median income. So this is the lowest income people. Well, I guess if you're making lower than that, you would still be cost burdened, but I guess not everybody is going to be able to afford a mortgage. But this is for people making only 30% of the area median income. Out of the single-family home supply, this is not necessarily the ones for sale or anything like this. So this is an incomplete picture. But there were only, there were less than 20,000 homes that would have been affordable to them. For the second category, people making 60%, there are quite a few overall in Davidson County that would be affordable. They could actually afford these ones or these ones. And then workforce, 1, 2, and then above workforce. So again, if you're interested in where can lower income people, which houses can they afford, it would be the first two bars. All right, so I put in, so I guess if you want to go back in the future to understand what I'm doing in these last few steps, I have some code in there that explains what's going on. But since I only have 6 minutes, we'll just go through this quickly. What I want to do is I want to look at how those categories have changed over time. And so I'm going to do a group by category and year. So I'm going to look at all of the affordable 1 houses across each year, and I'm going to get a count of those. I'm going to pivot those so that I end up with a data frame that looks like this. So this data frame tells us that in 2009, there were 32,000 homes that would be affordable to the lowest bracket here. 32,000 about in 2013, only 14,000 by the time we get to 2017. I'm going to reorder that, and then I'm going to put together a bar plot like so. So you can make side-by-side bar plots using Pandas and Matplotlib. And so this side-by-side bar plot gives us a little bit of an idea of what's happened. We can see that the first bar is 2009 and 13, so the supply was relatively flat. It even went up by just a teensy bit for the lowest income brackets. But then from 2013 to 2017, boom, dropped off, less than half. For the second, it looked like we had a relatively healthy supply of homes for people in the second bracket, but it's actually dropping as well. It's not dropping as dramatically as the lowest bracket, but it is dropping. And then those houses are shifting towards those upper income brackets, the workforce housing and then the houses that are above workforce. So I mentioned side-by-side plots are okay. But another type of plot we can do, and I'm scrolling, so I'm going to go down to this pivot df stack. I also like stacked bar plots. So I've got code here. I don't have time to go through it all, but I've also put together a bar plot, a stacked bar plot this time, where you can compare the years against each other in this way. So this is basically the other plot that we just had, but rearranged in a different way. So you can see in 2009, this is the total housing supply. And the bars at the bottom represent, this is homes that were affordable to those at the bottom, and then this is people that were making 60% of the area median income, and so on and so forth. And so you can see that drop again in these two lower bars. Okay, now since I only have 3 minutes, I'm going to do an extreme amount of hand waving here. But this plot this plot right here shows overall for Davidson County, the overall housing supply across the whole county. But what if we want to look at more fine-grained detail? What if we want to look by council district? So what I'm going to do, and then this will be, if you have no idea where any of these council districts are, here's where you can learn where they are. I'm going to read in a shapefile, and I'm going to use the GeoPandas library. GeoPandas is like pandas, but if you're working with geospatial data. So it'll allow you to render up plots pretty easy, or render up maps pretty easily. In addition, I guess I'm sliding in a lot of stuff here at the end, but I'm going to sneak in the Interact library so we can have a widget as well. So if you run this last cell, I've probably totally run out in front of everybody, but you got the code for when you go home. If you run that cell, it'll give you a warning the first time, but the second time you run it, it should be happy. But this plot is sort of the same plot that we just had, except looking at one council district at a time. And so if you're interested in looking at, well, what does the picture look like for Council District 5? And so what we have here is we have a map, and so you can see where in Davidson County. This map was created using GeoPandas. So you can see where that district is in Davidson County. It's right next to downtown in East Nashville. And then you can look at the breakdown of what did the housing picture look like. And so Council District 5, it's probably the most dramatic drop. But back in 2009, there was a very healthy supply of affordable homes. It dropped off a little bit from 2009 to 2013, but then all the hipsters moved in, and from 2013 to 2017, it's almost completely dried up, the affordable housing. So home prices are going up, people's rents are going up, people are having to move further and further out from Council District 5. There's a couple other districts I'll highlight because I'm right on time. So Council District 20, the one with the nations, that's another one where the affordable housing supply at the bottom is dropping by quite a bit. There are actually more houses. If you look at the overall supply, like the overall height, it's going up. There are more houses there, but unfortunately they're not affordable houses. In that area, a lot of times they'll knock down an old house and then they'll put up two expensive houses. And so that doesn't, I guess it doesn't help out lower income folks if you're knocking down old houses and then putting up two new expensive houses. So it's 10:30 now, so thank you guys for hanging in there for an hour and a half. There is some bonus material at the end, so if you want to learn a little bit about Seaborn or Plotly, there is some stuff at the bottom of that kernel, so you can check that out as well. So that's it. Thank you, guys.